Welcome to my Commodore 64 Games memories. This is where I look at old games and some of the technical details behind them. Let's get into it. Today we have Nebulus, published in 1987 by Hewson. Code and graphics were by John Phillips. I really enjoyed this game when it came out back in the day. I used to play it for hours. It's really hard and frustrating, but actually really enjoyable too. And it's got some interesting graphical techniques. So let's have a look at those. I'm looking at the original disc version. And what's interesting to note here is that this is using GMA 87, which is by Graham Ashton. And it's commonly called the bleep load, and that's because, as you can hear, it's bleeping in the background. This one's got quite an interesting little graphical effect where it's got this raster split moving down the screen, and there's a light blue area that's approximately stable down at the bottom, but then it's got this darker blue bar decreasing as it goes down the screen as the load progresses. I have a previous video where I go into a lot more technical detail about the GMA or Graham Ashton based protection code and turbo loader, so I'll link that in the video description below. I'm using the C64 debug GUI for this at the moment because it quickly shows us where the sprites are and where the other background graphics are. The red boxes highlight where the sprites are being drawn in this screen. I'm just moving all of these little sub windows out of the way so we can see the full screen. We have this rather good music in the background and a nice functional attract mode. In this view, where I'm using the targeting cursor to move the crosshairs up and down the screen, we see that there actually really isn't any variation in terms of character set or screen or anything else like that. And that tells us that there aren't any complicated effects in the title screen. In the game, we have this rather lovely effect where the tower and the platforms and everything else revolve around and the player stays centered. Now, this was a really unusual effect for the day. It had quite a surprise when I first saw it, I can tell you. And that's because it's a very non-standard way of scrolling the screen around. But actually, if we delve into this in a little bit more technical detail, it's actually not doing too much extra work compared to a game which has full screen scrolling, to be honest. There's a little bit of extra trickery involved in it, but it's not too bad. This game, I think it does render the frame over a couple of frames actually, so it's not updating at a full frame rate if I remember correctly. We can see where the sprites are. Now, the interesting thing to note here when we're looking at this is that when the sprites go around behind the platforms, they actually appear quite accurately behind the platforms and in front of the platforms that they should do. And they are also being drawn as sprites, so that's hardware sprites with these red bounding boxes. And we can also see that, so in the Commodore 64, each sprite can have a choice of appearing in front or behind of the background, in other words the characters or the bitmap, but that's only certain colours in the background, whereas these sprites seem to be appearing with pixel accuracy in front or behind of the things that they're meant to properly. So it looks like there's a little bit more sprite masking going on here. Now, the player sprite has at least two different sprites. We have a multicolored sprite behind a high resolution sprite or a non-multicolored sprite, high resolution sprite, which gives it the definition, the black outline. You might notice here that as the tower is being drawn, when I have the targeting cursor at this position on the screen, that you sometimes see underneath in the water the tower being drawn, and that's because the bottom of the tower is actually being rendered itself, but then it gets overwritten by a very fast draw of the water, but you don't see that because this game uses double buffering. We can see this game uses double buffering because on the right hand side, where the screen is being shown, we can see that the screen is constantly changing between two different values. Also note that the character set is stationary at 7800. So we'll use this information later on when we look at this in the ICU64 debugger. Here we are in the ICU64 debugger. The bleep load is just finishing, and here we go. So immediately in the graphics map in the second bank at 4000 in hex, I can see that there's some sprites. There's also some sprites here in the first bank, which is intriguing, but the main game sprites are here. If I switch between multicolor and single color mode, you can see, or high resolution mode, you can see the high resolution sprite overlay, which is usually rendered in black, has corresponding multicolored sprites. In the last bank as well, it's C000. There's also some sprites which seem to be the sprites that are used during the bonus section of the game. Now, the bonus section of the game is actually interesting, and we'll have a short little look at that too, if I can play through the level. Because this game's really hard. I'm just changing the graphics map text screens view here to show where those two screens are. And if I moved where the character set was, which was at 7800, there we go. We've got two double buffered screens. This game definitely needs to use double buffering. You can see more clearly the way that the bottom of the tower is rendered, but then covered over, if you like, by the water at the bottom. In the memory view here, notice this green blob, this green bar, which indicates memory reads, moves to the left and to the right as the player character moves up and down the tower. Also, depending on the tower's rotation, there seems to be a less frequently read bar of data across there as well. So this looks like quite a large table or area of memory being used for perhaps the rendering of the tower's data, because the movement of this green blob, which indicates reading, is definitely moving in synchronization with the player character as I move around. It's interesting to note that these sprites in the middle here are left-facing player character sprites, and then the right-facing player character sprites are up at the top. There's an awful lot of player character sprites. Now that's very interesting. Look at how the sprites are being masked in this area. When I say they're being masked, it looks like parts of the sprite have black chunks taken out of them. Now these black chunks, you may correctly guess, correspond to how the sprites are being obscured by parts of the foreground. In other words, the platforms or the lifts, for example, or the side of the tower, if the sprite is meant to appear behind the tower. This kind of masking effect was also used to great effect in Last Ninja, for example. Last Ninja used to dynamically decompress and actually mask the sprites for the player character and also the other characters in the game that should appear behind parts of the background. This masking is usually needed because the sprite priority register in the video chip hardware, in the VIC chip hardware, only pushes the sprite background priority for certain multicolors. It doesn't push it back behind all of the multicolors in the character. And in multicolor mode, the characters can have 3 different colors. Of course, color 0, the background color, is actually transparent anyway, so the sprite would show through that. So masking in this way is a way of ensuring that the sprite, what looks like the sprite priority, is completely correct on a pixel basis. I have a video about Last Ninja, and I'll try and remember to add that video link in the description below as well. After a while of playing, I think I've got to the top of the tower. I'm just anticipating that there was a falling away block there, but I don't think there was up at the top. That would be really unfair, wouldn't it? I'm just saving a snapshot now at this point so that I can get back to it more easily later on, because I don't want to have to keep on playing through the towers, to be honest. Now, this section is really lovely. You can see on the right hand side it's still using the double buffered screen. The parallax scrolling is basically using raster base interrupts for this section to give the smooth pixel level scrolling. And as we can see, the new tower bottom, which pokes out through the top of the water there, is actually sprites, but the rest of the stuff, the submarine and the fish that you collect, are all sprites, because they don't appear in the character's view in the graphics map. And this is the second level. It basically renders this in the same way as the first level, just with different platform layouts. I think there are 8 levels in this game that you have to get through. And as I say, it was really, really hard. Let's see if we can find out a little bit more about the rotating tower rendering. See how that works. I just zoomed in there on the text screen so we can see more easily the towers are actually using what look like the same repeating characters going down. It's just using a few animation frames for the rotation. This is just for the blue brick part of the tower. You can see as I go through the door, basically to avoid those enemies that come along, because the character set stays the same, we can just see that it's using repeated characters. Now the clever bit is actually how the platforms are drawn over the top of the tower. But if I zoom in here with the graphics map for the sprite view, you can see in more detail how the sprites are being dynamically masked. So let's find an area of the level. There we go. As that red one, or the grey one rather, appears in front and behind the tower, the sprite is actually modified in memory. It's copying over and using these slots as dynamic sprites. I think the sprites which are not obscured are probably just rendering from the non-dynamic sprites. I think it's just using the rest of the frames, because most of the time you would hope that most of the sprites are not obscured, because it's actually relatively time-consuming to calculate the obscured sprites. These sprites here, which are obscured by the edges of a platform, look are really, really obvious. We can see the cut-out areas of the sprites, the masked-out areas of the sprites there. So this is a really cool routine to get working and get right. Once it's working and correct, then it's a really powerful technique to improve the graphics quality of the game. Here in the top right hand corner, I'm looking at the debug view for the text screen, and I'm advancing the frame by using the Alt and plus key to advance one frame at a time. And we can see here in this debug rendered view that it's actually taking a few frames, maybe 2 or 3 frames sometimes, to actually render the full game screen. I'm advancing the frame one by one here, so look at the top right hand view there and then look at the real Commodore 64 view. You can see it's 1, 2, so we can see here that it's rendering what looks like the back side of the tower platforms first, and then rendering the platforms at the front side of the tower in a subsequent frame. So what we're going to do now is that we're going to look at what is rendering into a portion of the screen memory, which is one of the screens. This is the second screen bank at 7600 to 7700. Maybe that wasn't such a good area to look at because I'm actually looking at the zoomed in screen for the first screen bank, which is at 700 to 73FF, right? 73F7. Anyway, so this is the first bit of code that comes up when I'm looking at a memory watch breakpoint, if you like, or a watch point for storing into the screen memory here. If I look at the specific rows on the screen here, look using the I command or the II command, which just uses a different character set in this Vice monitor debugger window, I can count what is updating a particular part of the memory, and I want to basically trigger on a watch point on rendering that platform there. So I counted across and I saw that the platform is being rendered into 7198. That corresponds to that lowercase x there. So the first part is actually some code which looks like it's using an optimal tower edge clear. Basically, it's clearing the 3 or 4 characters. Yes, it looks like 4 characters because the load wire BFCF is going from 3 to 1 and then 0. But it's basically storing that on each row for that particular screen data there. So basically it's clearing the edge of the tower information. So note it doesn't actually clear the memory where the tower is. I mean, there's no point in clearing the memory where the tower is, where the blue bricks are, or the background bricks are. The actual bricks which make up the tower. It's not clearing that memory because it's going to draw the tower anyway, so there's no point in clearing it and then drawing over it again. It only needs to clear the parts of the memory where the platforms are being rendered, right? And that part of the memory where the platforms are being rendered doesn't cover the full screen either, so it doesn't need to clear the full screen. So it's already done a little bit of optimization here where it's doing this screen clear, this optimal 2 column area, if you like, the columns, the screen character columns to the left and to the right of the tower. So that's that routine there. That's going to be useful information for us later on when we're trying to understand the various stages of the tower drawing. The next watch point that triggers is actually inside this code here. Now this code here does a whole bunch of store indirects with 1, 2, Y, indirected, of course, with increment y, loading particular character code values. Well, okay, so this first bit of code here at C55E, C560, C562 is doing a load and then store. This AND is basically stripping out the lower 3 bits, bit 0, bit 1 and bit 2, by using the AND with $FC there. That's the current screen. Hopefully that's the same screen, because that's where I've got the watch point, right? So that's the command to display the whole screen, which is 7000 to 73FF. Just verifying that view with the view that I've got in the monitor debugging window as well. It looks like it's correct. The characters kind of like match up. So I'm not accidentally looking at the wrong screen, I don't think. And of course the watch point stopped on that particular memory address anyway, so it should be fine. So it's just about to draw, I think, this platform. It's already drawn some platforms, if you see. On the right hand side there, those 2 platforms at the bottom of the tower on the left have already been drawn, have already been rendered. We know that they've just been rendered because the screen area there has been cleared by the optimized column tower edge clip. So this is interesting, is that it seems to be altering the screen bytes with that left hand, probably a left hand or right hand edge of the platform mask there. I wonder why it's doing that. That's probably something to do with how the character set data has been laid out in memory. Because the horizontal screen scroll for the pixels is not being used. It's not being used from the hardware. It's actually got, oh, look at that. There's that lovely character set data there. And we can see that the character set data is mostly aligned to having vertical columns of colored pixels. So it looks like that bitwise and there is basically saying, you know, what is the existing color column information there for the graphics, and then please preserve it, but then make it so that I can start rendering some other graphics over the top which correspond to a platform with which is more in the foreground, perhaps. That's what it looks like there. So basically it's using the layout of the character set, by the looks of it, to ensure that it can quickly mask the left and right hand edges of existing platform color information, right? Because if your platforms are moving horizontally left or right between 0 and 3 multicolor pixels, you want to preserve the platform, what the platform looks like, or what the character set which shows the behind platforms. You want to preserve that information. But then if you're rendering, and that's only if you're rendering the left or right hand pixel edges of the platforms as they move on pixel accuracy. When you're actually rendering the middle portion of the platform, it doesn't matter. You can render or just the character. You don't need to worry about masking what is there previously. So this looks like a nicely optimized character set layout for how the platforms are rendered. So if we look in the debug view and we step over, we can see that the characters are starting to get introduced to the platforms. I stepped the instructions there and you could see that the platform was being rendered. And then it goes back through this code here, which seems to be doing a few increments and decrements and a branch on plus. This seems to be the end of the platform draw. And that seems to be so it's drawn the platforms here that appear behind the tower. It's now drawing the platforms which appear in front of the tower. This back to front rendering is of course logical, right? You don't want to have to try and deal with masking out character data of things that you're drawing from front to back. That would be quite problematic. But if I put a breakpoint at this code here, it seems to correspond to a kind of like a slightly more general purpose platform draw, right? Just updating my debugging notes, and of course these debugging notes are going to be committed to source control. If you sometimes people find these debugging notes useful. I think one of my watchers was, or viewers rather, was looking at my power drift, I think it was, video, and then got some inspiration to actually work on their own Petski character set racer. So I'm really happy to see that kind of thing happen as a result of people watching my long and waffly technical videos on old retro games. So yes, if you like these kind of technical deep dive videos, then please do consider liking or subscribing to this channel, or sending me a super thanks. They are all always very much appreciated. So I'm just looking around for extra draw routines now, because I have a feeling that it's not just platform drawing, of course, that we need to try and understand. It's also the drawing of the extra blocks and the lifts and the exits and everything else, and I think those are going to be other draw routines. So if I put a breakpoint here at the screen clear, so that we know that we're actually in the correct place. Here we go. Here's what looks like the start of one of the draws, and we can see from the CPU history using the chis command, the sys command, CPU history basically, that the code that calls this is that jump at C504, right, which is at C429 in memory. If I expand this text screen view so that we can see the both double buffered screens, and then I advance this routine, you can see one by one the platforms are drawing, then the tower gets drawn, and then if I advance if I let the CPU run and hit the next breakpoint, which is basically the same platform draw, the rest of the platforms in front of the tower should get drawn, right? So we know that we're in the right ballpark area, I think, for this routine here. Each alternate row of the tower data, look, is basically that repeating pattern. So the rotated tower is basically using, like the pre-calculated characters from the character set. It's just repeating that pattern. But it looks like a really nice effect, right? And it's a great effect. It's just using nice pre-calculated and regularly repeating rows as it goes down the tower. But if I advance here, you can see, look, the different sections of the platforms are being rendered one by one. The tower gets drawn on the right hand side. There we go. Oh, look. So it drew that lift and the platform all in one go. So definitely, yes, I think I need to find the other routines for drawing the lifts, the top of the lifts, the individual blocks and stuff. But yeah, basically this is showing how the screen is drawn up from the individual portions. Look, this code here seems to be reading from the table at CE00 and then storing using indexed Y from 0 to 15 there at C12C. Yeah, that seems to be rendering the tower data, right? And if I go to that area in memory and then apply the character set to that area of memory, yeah, that looks like the tower row the brick data, basically the tower segment tables. So depending on the rotation, it reads from those pre-computed tables there and then stores the character set data there too. So it's not modifying the character set, it's just rendering different characters that already exist in the character set, which is fair enough. So there's a table at CE00 and a table at CE40 there. Looks like the code at C0D6 there is loading accumulator with 47, ANDing it with F, probably to reduce it down to the number of angles that it can render. These 4 ASLs here are just the setup code which reads accumulator from 47 there and then multiplies it by 16. 2, 4, 8, 16. Each shift is multiplied by 2. And without counting it, I'm pretty sure that the tower as well, is 16 characters wide. So that's why there's a multiply by 16 there. So the tower draw is nice and optimal as well. It only needs to read the row characters once, and then it can store it multiple times, which is a very efficient way of doing it. Actually, if you like, the tower draw is actually doing less copying than a regularly, screen scrolling type game would be doing, because a regular screen scrolling type game would be loading and storing from each screen character set memory location, whereas this one is doing a load and then multiple stores, which is actually a lot quicker because you're not having to do a corresponding load to your corresponding store. Let's restore those breakpoints now at C504, and we can see that it's definitely, as I advance for each breakpoint, it's definitely rendering each kind of like significant portion of the tower, and that's because it's a breakpoint on the platform. That I mean the regular platforms, I don't mean the lift sections or anything else like that. Scrolling up and down through this area of memory in the code disassembly view, and I can see that there's a whole bunch of very similar code. Look, there's a jump there at C346, but then there's another corresponding routine just after it, which is doing slightly different things with the character data. It's rendering different things. And I just put a breakpoint on that other routine there. I can see there seems to be a common jump C3F6 as well. So that looks like each of these routines seem to return back to the same place in memory. Look, there's the other start of a different rendering routine there, which seems to render another different thing. I mean, the tower platforms and everything else, there aren't too many different types, right? There's a regular platform, there's a lift top platform, there's these characters for the blocks, and then there's the middle part of the lift, and then there's an exit platform. I don't think there are too many different other types of visual types anyway of the platform data or anything else like that. The parts of the tower that revolve around. I don't think there are any other types. This other code is certainly doing some loads and ands and ors and stores, which seem to be doing some pre-computed lookups for how the existing characters need to get modified when they are overdrawn with other tower objects. I'm going to call them objects because it's not just platforms. It's doors and lifts and other blocks and stuff like that, which you can shoot. So yeah, they are objects effectively, even though they're character based. They're still objects. But yeah, look, there's the routine. There's the routine here, which seems to do a load y branch on minus. I think this is doing some kind of like, look, see, there's a load A with AB E5, Y, AB FE, Y. There's that jump to C3F6 there, which is a repeating pattern. When reverse engineering this kind of stuff, repeating patterns are good, obvious, or semi-obvious, if you've got the experience, hints as to what the code is trying to tell you. I mean, everything has a pattern, and it's just a matter of trying to deduce the most logical explanation for these patterns to try and understand what the code does. And of course, is observation, the single stepping, the memory watch breakpoints, the code execution breakpoints are very powerful tools, and of course the debug graphics map views are extremely powerful tools for being able to visualize what the code is doing at particular points as you're trying to understand it and step through it to see what changes. Because you should be able to step through the code and then observe what goes on, and then to deduce the functionality or the broader functionality of the game code. So here it looks like it's loading the accumulator at that breakpoint there, which was highlighted in red. It's then doing a test on minus for whether or not it needs to render something. There's this broader loop here which seems to be doing some calculations based on what it's reading from these different tables in memory. So yes, the code at C3F6 is the common object return, object draw routine return address. That's going to be a really useful breakpoint to use, because putting a breakpoint here and then advancing the execution should, in theory, show each individual tower element being drawn. We should be able to track that now. Yes, and we can see here on the right hand side that each individual platform is being drawn. As I step for each breakpoint, it was basically drawing each platform, each object, each tower object, basically. The lift sections, the door sections, the platform sections. So advancing each breakpoint here, just keep an eye on the debug graphics map text screens there. The X command continues execution and then stops at the next breakpoint. So watch here as I use the X command, then all of the sections of the lift are being drawn there as it goes up the tower, and then it encountered some blank areas, and then it encountered some more platforms there. This is when it's actually drawing each row going vertically up the tower in columns. So it's going from bottom to top, upwards up the screen basically, or upwards up the tower. I think the start of the tower data is at the bottom basically, as it's reading it through memory. If you recall back to that green blob in the memory view, that was moving left and right. To the left is at the beginning of the table, and to the right is further along in memory. And that was only when the tower was going up, as the player character was going up the tower. And that's kind of obvious, right? I mean, beyond the bottom of the tower, it doesn't need to have any memory for that. You need the memory as you go up the tower, because that's the way that the game usually scrolls. So the question now is, how does the game read this memory to decide what to draw at what position in the tower? Because we know that we're stopping on each portion, on each tower object, we know that we're stopping on each tower object with each advanced breakpoint. So it executes. So the object is actually drawn drawn as separate individual objects based on each row of the screen, on each row of the tower. Look, the door was not rendered all in one go. The door was rendered as 3 separate rows, doink, 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 going vertically up. the segments of the extended lift are drawn one by one. They're not drawn all in one go, going up the tower. That's an important aspect to keep in mind, because it tells you the underlying data structure, or it gives a hint of the underlying data structure of the level that's being rendered. So starting at this point, the behind platform object is drawn there, and then stepping it again, the next platform object going up is then drawn. Again, this should appear behind the tower. It's a bit confusing because the tower has not been cleared from memory, but basically the tower has not been drawn yet. It's drawing all of the vertical columns that are appearing from behind the tower's edge first. Then there, look, the tower bricks got rendered, and then the vertical column sections are being rendered. Because the vertical column sections, especially the one in the middle, doesn't get obscured by any of the other ones, it knows that it can safely render those as well. So basically the way that the tower is drawn is from back to front, and different columns are drawn depending on the tower rotation, of course, also from a back to front orientation. This is really cool. I do really love the thought that went into this tower rendering code, because it meshes really well with the character set layout here. The character set layout for these vertical strips of color are what really make the solid looking tower rotation really work. Oh wow, look, this is a really good part of the tower to look at sprite masking. So this sprite here appears accurately behind the platform object. And I'm advancing each frame so you can definitely see each frame worth of masking. Wow, fantastic. That was a really lucky find. If you recall from earlier those extra sprites up in the top bank, notice how the sprite data is swapped around. It basically introduces the right facing characters, it removes them, it changes it so that the sprites have been copied or using the copied over data from the last bank for the submarine and the fish now. It goes into this intermission screen, and then into this bonus stage it's using the new graphics that were copied across. But it's only using the data which can be safely obliterated and copied over, because the left-facing frames for the player character are still there. So that it looks like there's some code there to flip the sprite, so that the code that flips the sprite is able to safely obliterate the sprite data for the bonus section, because then it can be restored later on by the code flipping routine, or the sprite flipping routine for the code. So that's interesting to note, is the amount of sprite shuffling or sprite data shuffling it has to do to accommodate the intermission screen, the game screen, and also the bonus screen as well. So there's quite a lot of sprite copying going on here, which is cool. You know, I do like that. It makes effective use of the sprites that are in the bank. It doesn't have to do too much bank flipping, which is a bonus, because you don't want to have to try and flip too many banks being used. You might want to try and copy in the data rather than having extra screens allocated in other banks in other memory and stuff like that too, right? Because each 16 kilobyte bank would need at least one character screen somewhere in that 16 kilobyte bank if you wanted to flip between different VIC banks. So just updating my debugging notes with a few of the interesting things that were found during this video. So we have the, the character set that was organized in such a way as to allow quick and relatively easy masking of previously drawn tower objects to preserve the horizontal or vertical bands of pixels, if you like, and then to superimpose or to mask on extra data on top of that for the platform objects for the tower that appear in front. So this character set, the layout of the character set is very, very important for how this game is optimized for its particular game view. The sprite masking, the dynamic sprite masking, was also a very important part of this game because it provides solid looking, layered 3D, if you like, for rendering the tower object. This is part 1. I think there's going to be a part 2 for this game because I want to try and understand the level layout, the level data layout in more detail, but that's for a later video. Thank you very much for watching. Take care, have a great day wherever you are.